Hi, welcome to Chapter 12 Notes Summary. You can see at the top here there's a word bank, and those are the words we're going to fill in these blanks as we kind of review through the different information we've covered in Chapter 12. So first up, it's showing you 3 pictures here, and the angle, location, name that we're looking at in these 3 pictures would be a central angle. Okay. And again, the angle measures compared to the arc is the same as the arc. Okay. And again, like we said before, if this arc is 100, then this angle is 100. If this angle is 50, we know this arc is 50. And if we know this arc is half the circle, which is 180, because the diameter is splitting that circle in half, then we know that that central angle is 180. Okay, next up, so that part's similar to the other review that we already did. Same thing with this part here. Just some good reminders that these angles, there's 3 pictures, are an example of inscribed angles. And they are half the arc. Okay, so if this arc is 100, I know this inscribed angle is half that, which is 50. Or if I know that this angle is 60, then I know that this arc must be 120. And same thing, if I know this arc is 80, then I know this inscribed angle must be 40. All right, so next up is we're reviewing over something we learned in section 12.4. So here you can see that in both of these cases, you see kind of an X being formed inside the circle. So that's our clue that since we see this inside angle, then we're using the formula that says 1/2 of the 2 arcs added up. So in the first example, we're adding up arc ED plus arc BC. And this arc from here to here and this arc from here to here is going to give us the measure of angle 1. Okay, if we look at an example off to the side here, say we wanted to figure out what angle 2 is, and we knew this little arc was 30, and we knew this arc over here was 100, then I could set this up and say angle 2 is equal to 1/2 of 30 plus 100, which gives me 1/2 of 130, which gives me 65 degrees. And again, if I find out what angle 2 is, I could always figure out what the angle right beside it is by subtracting from 180. I also know that the angle across from it here would be the same as angle 2 because they're vertical angles. All right, next up is also from section 12.4, and that is when the angle is outside the circle. Okay. In that case, we said this outside angle is equal to 1/2 of, in this case, we're saying this outside angle 1 is equal to 1/2 of the arc furthest away, which in this case is DE, minus, not plus this time, minus the arc closest, which in this case it's BC. All right, if we look at a specific example of that, again, if we wanted to figure out what angle 2 is, if I call that angle 2, and I say that this arc is 170 and this arc is 60, then I'll put the work over here. The measure of angle 2 is equal to 1/2 of 170. Make that 170 look a little better. 170 minus 60. So if I go 1/2 of 110, then I end up with 55. All right, next up is if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary, or they equal 180. And so in this case, angle A is supplementary to angle C. And we know that angle B is supplementary to angle D. And we also know that a quadrilateral, all the angles add up to 360. Something else that we learned that might help you. All right, a little bit more here. Next theorem says if a line is tangent to a circle, then it is perpendicular to the radius drawn to the point of tangency. The converse is also true. So it says RT is tangent if and only if OR is perpendicular to line TR. So again, RT is a tangent line, meaning it skims by the circle, touches the circle in one point, and forms a right angle with the radius. And that's going to happen if the radius OR and TR are perpendicular to each other. And again, the if and only if means that statement works both ways. The converse is also true. Next says if two segments from the same exterior point are tangent to a circle, then they are congruent. So in this particular case, we know these two lengths have to be congruent to each other. So we'd say AB is congruent to AC. Next up says that central angles are congruent to arcs, are congruent to chords. And all of those kind of go hand in hand. So in this particular example, if I know that angle AEB is congruent to angle CED, then I therefore know that chord AB is congruent to chord CD. And I also know that arc AB, which goes from here to here, must be congruent to arc CD. Okay, and then on section 12.7, it says if a circle, in a circle or incongruent circles, two chords and arcs are congruent if and only if they are equidistant from the center. So chords are equidistant from the center if and only if. So I know that in this case, if AB is congruent to CD, so if I know that this piece is congruent to this piece, then I would know they are the same distance, the chords are the same distance away from the center. Also, if I know that arc AB is congruent to arc CD, that would also help me know that. If I knew from here to here was congruent, then I would know those chords are the same distance away from the center. All right, on theorem 12.8 and 12.9, it says in a circle, a diameter or radius is perpendicular to a chord if and only if it bisects the chord in its arc. So in this case, it says that segment BA is perpendicular to segment DF if and only if arc AT is congruent to arc AV, and if and only if TU is congruent to UV. Okay, so again, BA is perpendicular to TV if these arcs are congruent, or if I know that these segments are congruent, then I would know these pieces must be right angles. All right, last little bit is just the equation of the circle that we talked about in section 12.5, that we have x minus h in parentheses squared plus y minus k parentheses squared is equal to r squared. We can see from the picture that their center is HK and our radius, it goes from the center out to the circle to some point XY. So again, the center of the circle is HK. So actually, whatever number is here, if you pay attention to that number in the sign, you basically do the opposite sign of that to get H. And then whatever number is here along with the sign in front, if you do the opposite of that, you would get this K part of the center. And then whatever this number is, you are going to take the square root of it to get just what R is, and then that would be the radius. So if R squared is equal to 25, then you know you would take the square root of both sides to get 5 for the actual radius. All right, that's it for the chapter 12 summary. And let me know if you have any questions.